好，因为我们现在一般上课只有16周啊，所以我现在上课的速度会比我以往快一点啊，所以有些废话我就不太讲啊，或者笑话。So we have learned a few things. That first, the locus of the E vector is in general an ellipse. And the second, that the orientation of the major axis can be determined by the originally given amplitude AX, AY, and the phase difference delta, which is equal to delta Y minus delta X. And the third thing that we learned is that we can judge the sense of revolution according to the sign of sine delta. Okay. Okay. 我刚刚突然想起我刚刚其实忘记讲一件事。好 ，I forgot to tell you one thing that we might use later. This thing is about a squared plus b squared. A squared plus b squared is equal to ax squared plus ay squared. And a times b is equal to ax ay times the absolute value of sine delta. Okay. This relation is obtained through this taking the determinant of both sides of this equation. N minus is equal to st m inverse s. Okay. According to linear algebra, we know that if we calculate the determinant of both sides, okay, and linear algebra tells you that if we multiply two matrices and calculate the determinant of the product, then the result can be factorized as the determinant of first matrix times the determinant of the second matrix. And also we can write the determinant, we can calculate the determinant by exchange the position of the two matrices. So if we exchange this matrix, the order of this matrix and this matrix, we get determinant as st times S inverse. However, st is the inverse of S, so this tells us that this is just the determinant of M inverse. Okay. You might remember that the relation between N and M is just the so-called similarity transformation. 相似变换. Through similarity transformation, the determinant of the matrix will not be changed. Okay. So we can calculate the determinant of N inverse by calculating the determinant of M inverse. In linear algebra, there is another important quantity called trace. trace trace means the sum of the diagonal element of the matrix, and its notation is TR. Okay, so if we calculate the trace N inverse, it is equal to trace ST M inverse S, and the trace is also unchanged if we do similarity transformation. So trace N inverse is equal to trace M inverse. Okay, the sum of the diagonal elements of the matrix. So what is the sum of the diagonal elements of N inverse? It is just A squared plus B squared. And what is the trace of M inverse? Remember that what is M inverse? M inverse is just this AX squared, AY squared, AX, AY cosine delta, AX, AY cosine delta. Okay? So the trace of M inverse is AX squared plus AY squared. So this we get this result. Okay? And how about the determinant? N inverse. The determinant of N inverse is just A squared times B squared. Okay? And the determinant of M inverse is AX squared, AY squared minus AX squared, AY squared times cosine delta squared. Okay? And the 1 minus cosine delta is equal to sine delta. So this is AX squared, AY squared times sine squared delta. And we take the root to obtain A times B equals AX, AY times the absolute value of sine delta. Okay, this is because sine delta can be negative sometimes. Okay, and we must take the absolute value to get the positive quantity. Okay, so these two relations, these two equations are useful later. 好，我们等一下会用到这两个关系式啊。那现在有一件事再提一下，就是刚刚讲到说关于这个电场它是怎么转，是逆时针还是顺时针啊？那这个逆时针、顺时针究竟会影响到什么？啊 What does the sense of revolution imply? Okay. It implies the direction of angular momentum of photon. 啊，就是说，我们知道光其实是有角动量啊 ，photon carries energy, momentum, and angular momentum. Okay, the angular momentum of photon corresponds to the so-called spin of the photon. An electron is a spin 1 half particle, corresponds to so-called fermion, and the photon is a spin 1 particle, which we name it as a kind of boson. Okay, and the quantum part the angular momentum正负 h bar 啊，一个光子的这个角动量正负 h bar， 这个正负是什么意思呢？是说，假设这是 k 方向，光子传播的 k 方向，好，那它的 angular momentum 如果是跟 k 平行的同方向，这个就会得到一个 h bar 乘上传播方向的单位项啊，the k is equal to the magnitude, the k times the unit vector along the propagation direction. Then a photon can carry a angular momentum parallel to the k vector. Then, if the sign is positive, we call it positive h bar. However, it can also be along the opposite direction. Then, in this case, a photon has angular momentum minus h bar. Okay, positive or negative h bar along the propagation direction. And this case corresponding to the sense of revolution counterclockwise sense. And this corresponds to the clockwise sense of revolution. Okay, and some textbooks give a reverse definition about the sense of revolution. It is because they use a different way to see the so-called sense of revolution. 就是说，我们这个书里面啊，当我们讲到右旋光的时候啊。This, if we consider the circular polarization, this is called right-hand circularly polarized light. Okay, and this is called left-hand circularly polarized light. But in some textbook, the definition is reverse. Okay, 就有一些书它的定义是跟这个反过来，好，反过来原因是因为我们这一个书的定义是说，我现在站在这里，我看着波一直过来，我看这个电场究竟怎么绕，逆时针绕还是顺时针绕？但有的书它不是这样，它是给定一个时间，然后呢，你想象说我这个电磁波冻结在那边，然后我从这个点移动到另外一个点去看它这个沿着 K 的方向，它究竟是逆时针绕还是顺时针绕，然后来给出正或负。好 ，So according to our textbook, the definition of right hand or left hand is defined as this: I see a wave propagating toward me, and I see what the E vector revolve. If it revolves counterclockwise, I call it right hand circularly polarized light, and if it revolves clockwise, I call it left-hand circularly polarized light. However, in some other textbook, they treat the wave as frozen shape and see while the E vector revolves along the K vector. If it revolves along the K vector in a right-hand sense, then they call it right-hand circularly polarized. And if it revolves like the left-hand sense than call it left-hand circularly polarized light. Okay, so these two different definitions give us different results. In our textbook, we use this definition, and according to Coach Ye, he says that this definition is the same as in the particle physics definition. OK， 就在粒子物理里面的关于光子的这个角动量正还是负的定义，跟这边的右旋是一致的啊。好。So now we see some specific examples. In general, we have an elliptically polarized light, and in some special case, we may have circularly polarized light and